Alright, hey everyone, how's it going? Today I'm going to be doing some C++20 ranges stuff. Well, stuff which didn't get into C++20 ranges, but is nice to have. So I'm not sure which ones I'll get done. I haven't implemented these before. I think I'll start off with enumerate, which is super useful. And then maybe do cycle, which cycles around a range, just making it into an infinite range. Hey Oliver, hey Leslie, everyone. Maybe do Cartesian product. I'm not sure. We'll see how we go. Maybe we'll get one implemented. Maybe we won't get any finished. Maybe we'll get a few. But gonna switch over to Visual Studio here. Okay, so I have already set up my CMake project because I didn't want to do that. For every CMake project that I do for one of these now, I steal the CMake from one of my other projects, which is enumerate wrote the CMake for, which I'm very, very grateful for, because it's actually CMake done properly. Hey Glenn. So this does everything that I need. You can even build RPM packages or dbeam packages or MSIs from this. Kind of cool. But yeah, this is just a CMake me down. Yeah, this is a bare bones. Well, not bare bones, but I don't have any code, any C++ code in here yet. I've got an empty folder for my headers, and I've got an empty test folder. So we'll start off making test. We'll start off with enumerate. Oops. Oh, I didn't even realize that this pops up now. Proposed CMake script changes. I haven't seen this window before. I mean, okay, apply. Sure, why not? I don't know what changed, but we'll go for it. Okay, yeah, that was a little bit weird. Include catch. Okay, so what I want for enumerate, if you're not familiar with it, is it's basically a way similar to something like in Python, where you can say, if I have say it's a std vector. Come on. Don't lock up on this. Happened last time as well. Visual crashed right at the start, and then it was fine for the rest of. Here we go. Okay. Start with the vector. 1, 2, 3. Then you could say for index item in enumerate A. So basically what it does is changes our range here, which is our vector, into something which doesn't just give us back our items, it gives us back our index and the item. So then I could say something like, not piecewise construct distribution. We could say something like at index item, and that will print out the index and then the item. Cool. So this is the kind of thing that we want. Now we could implement this with the generator that the coroutine generator I implemented last week. I benchmarked this a little bit. The coroutine version is a lot slower right now, which I think is because coroutine implementations and compilers are still, fairly early, and also I did not try to optimize my my generator type. So we're gonna do this by hand, writing the full C++20 ranges code for our enumerate type rather than using a generator. But I will be looking into why the coroutine version is slower, because like in theory, want this to be as fast as it can, right? So that you can write a super simple generator code and have it optimal. So you don't have to write all of this ranges nonsense. All right. Yeah, I don't know what this is about. I'm gonna have to talk to people about this. What am I using? Oh, I'm using my. Okay, this is coming up because I accidentally am using an internal build of Visual Studio, so you shouldn't be seeing this. Maybe something cool is coming. Hey, thanks to the subscription binaries. I should probably switch. You know what? Yeah. So that I don't accidentally, like, none of this is secret or anything. Like, this stuff is going to be coming in like the next preview release. So, I'm not like breaking any rules or anything. I'm glad the caption, closed captions on streams like this are difficult. Right now I'm using this thing here. It's a stream closed captioner, which I just set up as a an overlay on Twitch. So the captions are not great, but hopefully they are better than nothing. Like this seems mostly okay. But yeah, it is important to me that I have at least something available. And then when these videos go on YouTube, I always fix up the captions before they're uploaded. Did I open up Visual Studio? Seemed like it was doing... There we go. Okay. Give this a second to... I think this should pick up the repo that I was just on. If I give it a second... No? No? Okay. Alright, repos, what was it, ranges. Okay, this will be better. Now I won't have any surprises of things that are coming up in the next release, just popping into stream. So yeah, we're going to do enumerate first. And the basic idea is that we want to make sure that our implementation is correct for different kinds of ranges, underlying ranges, right? So like if you have a vector, then that's a random access range. You can jump all around a vector. Whereas if you have something which is not a random access range, if it's just, you know, bidirectional or whatever, then you don't want the enumerate range to be a random access range. That should be a bidirectional range. So that's something that we're going to have to be a little bit careful about while this is loading. So there is a standards paper for enumerate written by Corentin, which is a little bit more than what I want to do today. Let me find it. So one of the sticking points about enumerate is what should the return type of dereferencing the iterator be? Should this be a std pair? That's easy. But then it doesn't give you nice names, right? Which is first and second, and I always forget which way round these things are. It's like in this paper, you really want like an index and a value names, but then you need to write like a ton of other code to get it to work. So that's kind of a pain. I'm just going to use std pair here because it's a lot easier. All right, so we're loaded up again. Include enumerate. Okay. Gonna have my TL namespace, and my class is going to be called enumerate view. So the usual way which we do ranges right now is we have something which is suffixed with _view, which you can construct and play around with. So like ranges drop view. So you have an _view type, which you can construct and use as a view. And then you also have in the views namespace something which is just called drop. And that's something that you can pipe things into. So you could construct a drop view, or you could pipe things into views drop. We want the same thing for enumerate. So we're going to have an enumerate view, and then we're going to have namespace views, and then the usual pattern here is something like namespace detail class enumerate fun, which will be an enumerate function, and then you have an inline variable expr enumerate function, detail enumerate function enumerate. Okay, so this will allow us to either just use it like this as if it was a function, or to even just pipe a into TL views enumerate like that. So there's a couple of different ways we can use this. Okay. So what do we want when we have an enumerate view? So enumerate view, just like something like drop view, is going to be templated on some other view, right? Because you want to be able to construct this with a vector or a bidirectional range or an input range, hey, thanks to the follow button. So we're going to do the same thing here. Okay. So this is going to be our enumerate view, and we're going to have to capture this view somewhere. So we'll call that base. This is our the range that we're constructed with, like our vector. So if we construct an enumerate view, then we're going to take our v and store it into base. You're forced to use CRTP. So yes, generally you want to use CRTP here. View interface is a helper to make your own view type. Basically it adds a bunch of additional things like providing empty, operator bool, data, size, things like that. And that is using CRTP. CRTP, if you're not familiar with it, is essentially providing your own class name as a template parameter for a base type. So we want to do the same thing here. Oops. Stud ranges, view interface. And pass it enumerate view. That's our CRTP. I think that's right. Okay. All right, so now we have our constructor. So for some of this stuff, I'm going to look at the paper here because it means that I don't have to think as much. And, you know, Contan's already thought a lot about the kind of different ways that the type needs to be used, which makes it easier for me. So the thing about views in C++20 ranges right now is they need to be default constructible. So we're going to say that here as well, that our enumerate view, we do have a default constructor, but we require that is default constructible v. All right. And note that we also are templated. Sorry, this is our result type, isn't it? I'm looking at the wrong thing now. Yeah, that makes a lot more sense. We just have a default constructor. Okay, so we're default constructible because views have to be constructible. And then we need to be constructible with an instance of our base. Okay. So that is our default constructor and our base constructor. Or is this a, I can never remember what the, whether this is going to end up being a reference or not. Guess is this mentioned down in the constructors? No, it's not. Well, anyway, we'll keep it like this for now. Okay, so the things that we need for any kind of range are iterators and sentinels. So if you have a look here, I'll zoom in a little bit so it's more visible for y'all. There we go. So in this case, we've got an iterator and a sentinel, and these are also templated on whether the base is const or the range is const or not, because if you're familiar with things like a std vector, if you do begin, then you'll get back a non-const iterator unless the vector is const, and if you do C begin, then you'll get a const iterator. So we're going to do the same thing here. Template bool const iterator and template bool const sentinel. Cool. So there's a bunch of different cases for begin and end here, right? Depending on whether our view is const, depending on whether on what kind of view our base range is. This will result in different behavior for begin and end. So there's a few different options here, which look back at simple view. I can't remember what simple view is. Is that something which is already defined? Or is that something which is made up here? Simple view. It's not even defined here. Okay, maybe we can intuit it from the code. So this is returning a non-const iterator, and this is returning a const iterator. Yeah, I'm not sure what this simple view is. Oh, I guess is this... There's an exposition only thing in here, so let's go have a look at that. Simple view. Here we go. Simple view is if something is a view, and if the const version is a range, and the iterator for the range is the same as the iterator for const range, and sentinel is the same as const sentinel. Okay, we can copy paste this. Stick this up in a detail namespace. Template. This class, or is this? Yep. Concept simple range is this. So if you're not familiar with defining your own concept, this is how you do it. It's just essentially like a boolean, a const expr boolean. So we can define that up here, and now we can use it later on. So let's go steal some of the code from the paper. Simple view instead of simple range. Thank you. Okay. So isn't there any keyword like inline or const expr required? No, there used to be, like, in the syntax has changed over time. Nowadays, you just need to say it's a concept. So we return a non-const iterator if our enumerate view is non-const and our underlying input range is not a simple view. So we can go ahead and I'll just copy paste those and hope that we don't get any weird PDF issues. Okay, this will need to be detail. I think our concept here was also, this says that our underlying base should be both an input range and a view. So let's go and do that as well. Input range and requires ranges view. No, not swap ranges. I think this is because my CMake, I don't specify C++20. I do, but maybe that's not picked up by... Let's regenerate CMake and see if we get better IntelliSense. Gathering information. Anyway, let's see what else we can do. Okay, so let's begin. And then there's a few more different options for end. There's end when our enumerate view is non-const. And there's end for when our underlying view is a common range and a sized range. So a sized range means that we can work out what the size of the range is in constant time. Basically, if it's, like a vector, what you can get the size of it in constant time. It's like the end iterator minus the begin iterator. For std list, you can get the size in constant time post C++11 because they specified you had to be able to do that. So like they would keep a member around. But say you had a linked list which didn't track the size, then getting the size would be non-constant time, and there wouldn't be, and therefore your range wouldn't be a sized range. Yes, so the enumerate view, I can show that again quickly. The view interface is here. So you give it its own type as a template parameter, and based on that, the internal implementation of view interface is going to do some casting internally and essentially define some of these member functions in terms of the functions defined here. So it's like people in chat are saying, it's like kind of like mix-ins. It lets you get some extra behavior based on the behavior that you've implemented in your type. Okay, CMake generation finished. Maybe we get better IntelliSense now. No, I had no IntelliSense luck on these streams. Okay. So yeah, I was just explaining what sized range was, when you can get the size in constant time. Common range. So let's go have a look at common range. Common range says that your type is a range and the iterator is the same as the sentinel type. So used to be that, you know, if you're writing iterator-based algorithms and things like that, or iterator-based containers, that your begin and your end iterator would be of the same type, right? Like for a vector, then you could think of both the begin and end iterators just being a pointer into the contiguous buffer. And so you know when you're got to the end because your end iterator will be the pointer right past the end of the contiguous array. So you know when you got to the end because those two pointers will be equal. But for some ranges, then the sentinel type, i.e. the end iterator, is going to be a different type than the begin iterator. So common range is saying that your range and your begin and end iterators are of the same type. All right. Oh, and then this rephrases what I just said in probably slightly easier language. Yeah, all the standard library containers do this. Not very good naming. Rather call it legacy range, maybe. When's it useful to have different types? So for example, in my generator that I wrote last week, in my generator, the end iterator wasn't really anything, right? You didn't have any state to compare it to. In fact, literally the sentinel type was an empty class. So the end iterator, when I return end, which is down here, I literally just return this type. The only point of this type is to is here when we compare them. It's basically just a way of checking if we're done. All right. Cool, makes sense. And so in this case, because we do have an underlying range that can be, you know, any kind of range, then we want to kind of preserve what the underlying range is doing. We want to, if it is a common range and a sized range, then we want to expose that in our enumerator type as well, which is why we use concepts here to have different behavior. So, you know, the common range, thanks to the follow binary string. So this is like I said, in common range, the begin iterator and the end iterator are of the same type. So you can see it does the same thing here. It returns a begin iterator and an end iterator of the same type, preserving the behavior. I think this subscription bundle. Okay, and then finally we've got these two for const and non-const. Again, checking whether we're sized and the begin and end iterators are the same type. So again, I'm just going to steal these. This is why it's nice to have someone else write a paper for you. You can just copy paste all their code. What's the... There we go. Oh, that's still giving me some weird formatting. Let me fix this a little bit. There's the... Yeah, formatter getting a little bit confused here. Am I using Clang format here? I feel like I... Yeah, that's what I'm pressing. KD. Go check my Clang format settings. Because I feel like that should be giving me better formatting than that. Run Clang format for all formatting scenarios, yeah. Switch to LVM, see what happens. That was even worse. I know, that's not too bad. If I add in some extra new lines. Still kind of there, but let's try one different style. Chromium style. See how that looks. Hardly different. Okay. It's formatting, it's fine. Let's move on. Yeah, when we've got our requires clauses and things like that, I feel like Clang format is still catching up a little bit on requires clauses. But anyway, it's mostly okay. Like, this is kind of weird. You can see that it's getting confused whether something is a... I think that obviously thinks to format this as an R value reference, rather than a conjunction. Okay, so we've got our begin and end. Our iterators and sentinels aren't implemented yet, but it's fine. We can do that. Okay, size. Like I said, you only have size if you are a sized range. Otherwise, you don't want to have a size member. It's not going to be great. Add, like this. Yeah, it does get onto its own line, but yeah. Yep, so we got our size, requires that our underlying type is a sized range. Okay, and then we have this base function. That's a way to get into a view and pull out the base iterator. And again, we can just steal this implementation. Writing C++ is easy. You just copy paste stuff from other people's work. Okay. Oh, this is the constructor I was looking for earlier. Yes, we did do that. Okay, cool. And then this right here, this is a template deduction guide. What this does... Whoops, that did not... There we go. This says that if you construct a enumerate view with some range, then this is what it's going to deduce to. An enumerate view of stood views all t are. Let's go look at what all t is. Whoops, wrong one. Here we go. So all t is a range adapter that returns a view, includes all of its elements as its range argument. So this is essentially just, my understanding is it's just turning it into something which is a range and which is a view. And could give you a ref u or a subrange. Do we need to do remove reference t? I think that's handled by this here. If we give all t something, then it's going to get decal type of views all, so that will handle the reference. We don't have to do it. All right, cool. So that's our main view type. Like I said, we're not going to do this enumerate result t. I'm just going to use std pair. Okay, iterator. So our iterator type here is going to be either a const iterator or a non-const iterator. And so our base is going to be either what we're given as our template parameter to our view, or it's going to be a const v if our iterator type is const. So we can go stick that in here. Count type. So count type is going to depend on whether we are a sized view or not. If we are a sized view, then we're just going to use whatever that that type is the size would return. Otherwise, we would have to use the type that you would get from subtracting the begin iterator from the end iterator. And I feel like there's some helpers which can do that. So ranges size t base, if base models ranges sized range. So I just said this is the type which size will return. Otherwise, the difference between the iterators. Okay. Count type. Include type traits. So this is either going to be if std ranges sized range v. If it's a sized range, then we're going to use std ranges, what's it called again? Range size t of v. Otherwise, we're going to use std make unsigned t of std ranges range difference t, I think is it? Range difference t v. All right. Range difference t. Yes. Okay. Hey, that actually formatted it fairly decently. Do we have the problem here that these things are going to be eagerly evaluated? I cannot remember what happens if you try and get range difference. That shouldn't be a problem, right? You should be able to get range difference t on anything. What happens if you try and get range size t on something which is not sized? Just gonna look this up. Range size t. Decal type of calling ranges size. This is something we can test for, right, and see what happens. Is sized range a Boolean constant or a type trait? Sized range is a concept. pretty sure. Yeah, concept. So we could just use it like that. Okay. All right, so that's our count type. Where were we? Yeah, and then we need to store the iterator type to where we're currently iterating over in the base, and also the current position that we're at, because we're going to be returning the index as well. Did ranges iterator t. Wish you could write. Can you write auto there? I can't remember. This will do. Okay, and then we need all of the usual iterator types, like getting the underlying category of our base iterator, getting the reference type, if you dereference the base iterator, what's the reference type, the value type, any reason for not aliasing ranges. No, I could definitely do that. I am in a header, but yeah, I could alias it to something in a different namespace, but this is okay for now. This needs to be public. Yeah, I think you're right. Yeah, we can just do that. Okay. Std iterator trait, std ranges iterator t, enumerate result t. I don't actually know what that is. What is that? Enumerate result t. Look what's up. Oh, that's our type there. Right, of course. Silly me. Okay. Our reference type is a std pair. Of our count type and our reference type. And here, it's a std pair of count type and the value type. There we go. And then our difference type, if you subtract one from the other, then it's just the same as the base. Yeah, no, it's std pair type. Okay, so all iterators in ranges need to be default constructible. We need to be constructible with the base iterator we're wrapping over and an initial position. And then we can potentially convert our non-const iterators between each other if so this is saying that we can convert a non-const iterator to a const iterator, but we can't convert a const iterator to a non-const iterator. Yeah, it's bull. It's the template parameter up here. Go copy these. Okay. Is it std ranges iterator t? I think so. Range difference t. I need that. I can just use difference type, since it's going to be the same. Okay, and then we're going to initialize current with current and pause underscore with pause. Yay. It doesn't need to be explicit, right? It's not a single it's not a single argument constructor. I guess we'll leave it in, but so we can take an iterator, we can convert an iterator if the iterator is const and if the iterators are convertible to each other. And that will do current underscore is I dot current, and pause underscore is I dot pause underscore. All right. Clang format getting very, very confused here. Okay. Then this gets our base, which is the current iterator right here. This gets our base if we're an R value. So do we need different behavior here? Oh, we need to move our iterator here. And here. And then, yeah. So in the case that we are called as an L value, which is this constant, then we return current. And in the case that we're called as an R value, we return smooth current. Nice. Okay. So then we've just got a bunch of mechanical things to do. You know, we need to be able to dereference, which is going to give us our std pair, which is up here, our std pair type, with pause and current. We need to be able to increment our okay, so this is the case where we want to only give our the correct member functions depending on our base. So we want to be able to pre-increment whatever, but we can only post-increment if the underlying range is a forward range. And likewise, we can only go backwards if it's a bidirectional range. We can only jump forward and back if it's a random access range. All that good stuff. So I feel like we can probably breeze through these fairly fast. Incrementing our iterator means we increment current and we increment pause. Doing a post increment means we oh wait, sorry, return this. Doing a post increment means just calling operator ++ and casting it to void. Wait, what's the difference between these two? So if our underlying range is not a forward range, then we're returning void. Otherwise, we're returning our iterator type. So we want to say our iterator type what do we do here? We We want to call. We make a copy of ourselves, and then what's the behavior say down here? Just want to double check. Okay, yeah, just the usual. Make a copy of ourselves, and then increment, and then return the temple. And just gonna copy paste it. Is our pause underscore? Yes. Oh, I think is that a typo in the paper? Got pause underscore here, and pause without underscore here. And then subtracting is very much the same. Required to be bidirectional. So just minus pause underscore minus current underscore return this, do cast void operator minus do, because this one is returning by value. Minus pause, minus current, return temp. Okay. Then jumping around, we do pause plus equals x, current plus equals x, and return this. Same deal here. Oh, don't lock up on me. There we go. Ah. All right. And then this, I think this should be fine. Just casts our difference type, and then increments our current one. All right. I think that should be fine. Yeah, it looks good. Okay, we're getting there. Seeing all of the boilerplate we're having to implement here, just to get our range stuff working in the face of, when things are common ranges or sized ranges. It's all kind of a mess. Okay, then we need all of these things. Do we really need all of these things? Like, how much of this stuff can the compiler implement for us because of the spaceship operator? I can't remember where those rules ended up. Does anyone know off the top of their head? Because this is just doing current. I feel like we only need this one and this one, right? Well, I'm gonna do that and see if the compiler complains at me. We need the where are we? Iterator type up here. We're just gonna return if x dot current equals y dot current. And then for this one, we're just gonna defer to x dot current spaceship y dot current. Cool. I feel like that's enough, right? Compiler should generate the rest for us based on these definitions. And it's not like you could do much optimizations based on this. There are many comparison ops needed if the value is not three-way comparable. Oh, yeah, I guess if the underlying iterator is implemented in a weird way, then technically... alright, fine. Let's just copy paste this. We still need it to be a random access range, but we don't need it to be three-way comparable. And how many of these things do we need? 6. 1, 2, 3. Oh, just 4. 1, 2, 3, 4. And with that, with less equals and greater equals. Boilerplate. Okay, that's painful. Always wondered how they figure out what was boilerplate is necessary. Yeah, there are... Yeah, you basically just need a bunch of tests for all this stuff. Okay, and then the last thing in our iterator type is plus and minus, which are down here, and it's equivalent to just using the operations we already defined, essentially. Whoops. I haven't even tried to compile this yet, and we're like an hour into stream. Definitely gonna have to fix up all these namespaces. So for this, we return just a copy of x plus y plus equals y. That should work, right? Is that? Yeah, that's exactly what it says there. This way around, we can just defer to the one we just implemented, and then we can do same song and dance. Yep, iterator return, iterator x minus y, and then return y minus x. Okay, that's our iterator type. How much more code we got to go? Almost there. Just our sentinel. So the sentinel again is templated on whether it's const or not. I'm going to steal these exposition only members. Std conditional. If we're const, then our base is const v, otherwise we're v. And std range is this std range is sentinel t? I can't remember. Ranges sentinel t. Yes, it is std range is sentinel t. Okay, cool. And we can do the same thing we did for the last one. Public. Okay, where were we? We need to be default constructible. I'm just going to copy paste this whole thing. We need to be default constructible because sentinels need to be default constructible. We need to be constructible with a base sentinel, in which case we're going to just move it. This is again our converting constructor in the case that we're converting non-const to const, which is going to steal other dot end. Std move. Okay. Base. Returning base. Obviously not caring about whether we're an L value or an R value in this case. And then, okay, so this is the comparison from an iterator of the same constness as us to a sentinel. And this will work for comparing a non-const iterator to a const sentinel, because the non-const iterator will use the converting iterator constructor, bind to a const L value reference, and then it will work. I'm pretty sure. Okay, we did that. Did that. Okay, yeah, we're just comparing our x.current to y.end. We're gonna have to make sentinel a friend, aren't we? Yeah, I'll just do that right down at the bottom here. Friend. How do you even friend a template again? Is it... Template friends are one of the most horrible parts of C++. It's so bad. Is that right? Oh, I can't remember. We'll see what the compiler shout says. That compares, and then we just need our addition and subtraction. In which case we do x.current minus y.end. And then in this case, we do, where'd that go? There we go. This is taking iterator away from a sentinel, do x.end, take away y.current. Okay. Let's compile. See how many errors we get. Okay, immediately getting cannot open catch.htpp, which I feel like should have been gotten in our CMake file. Does fetch catch, oh, catch2/catch.htpp. I feel like the next at least 15 minutes is just going to be bashing compiler errors, tl/enumerate. There we go. Okay. Std ranges. Enumerate view. Unspecialized class template cannot be used as template argument for template parameter. Read that. Argument list missing. Okay, we just need, you know, is it std ranges range reference? Yes. Oh, no more. Okay. Just gonna copy and paste this because I feel like I'm gonna need this. All right, let's run down See what we're missing. Std convertible to argument list missing after iterator t. Std. I feel like that's just in std, or is that in ranges as well? No, it's std ranges. Oops. Std ranges iterator t, ranges iterator t. Std copyable. This is what you get. This is what I get for copy pasting code from standards papers. Random access range. Quality comparable. Should have just done a search and replace here, but I'm committed now. Did it for that one. Still so many compiler errors. Operator less than. Got an additional. Yes. I feel like, was that an error in the paper as well? This is the fun part of coding, right? I need to have already declared Sentinel to make it a friend. Then I can make it a friend and everything should be good. Invalid friend declaration. C++ friend template class. What is the magic incantation? Template friend class foo. Okay, we don't use. We don't give it a template argument. Swap ranges. Oh, it's just. So many of these simple names as well. Std ranges size sentinel for. I'm not complaining. They could be a whole lot worse. I just control clicked on that. We're going into the standard library headers. Std copy constructible. Alright, like we're getting there. Slowly. Sentinel T. And here. And here. How many errors are at? 36. Errors, 250 lines of code. Come on. Oh. It's too many namespaces. I do have hash include ranges, I hope. Yeah, I do. Size Sentinel 4. It's not. That's just in std. Not std ranges. It's an iterator. And the same again here. Current identifier not found. Missed my underscores. Okay. "27 errors, we're getting there. Okay. This looks like I closed brace too early. Member function already defined. Oh, I've just defined those twice. So close. Six errors. Okay, so now we're at like. Okay, right. That's an actual error. That's something we've not done yet. Is enumerate fun. So, let's see, is this in the paper? Operator bar. No, it's not. Interesting. Okay. So to implement this, we have a call operator which returns an enumerate view, which is templated. I think we want to make it look like const expert auto enumerate view for, actually, no, we'll just do context per auto operator call with, this is gonna have to be std range, which is input view v. Oh, yeah. Make public. Ref. And return TL enumerate view. Thanks for the follow, David. With stood forward v. Okay. So that will allow us to call enumerate and get enumerate view back. Then, oops. We also want a friend. Yeah, this is just a, yeah, we could just make a struct, but it doesn't matter, same thing. Yes, I've been at CPPCon a number of times. We also want a friend, context per auto. Should accept any viewable range, input range, not only views. Ah, yes, you're right. Friend context per auto operator bar. So this is what will allow us to pipe something to enumerate. And this will also be a template. And it will take take our viewable range on the right, on the left-hand side, and our enumerate function. Oh, this needs to be const. Our enumerate function on the right, and then does the same thing. View stood forward v. I think that's right. Let's give it a try. And then we've got a global inline instance. Okay. Atomic constraint not satisfied. Should be a constant expression of type bool. Which one's that? Okay. So couldn't do an equality operator. TL enumerate view operator equals constraint was not satisfied. So many templates. Okay. Std ranges ref view. So this is our ref view of our vector. Iterator, true. So that's our const vector iterator, I guess. And TL enumerate view iterator false. So it looks like our way trying to compare a const iterator to a non-const iterator is not working somehow. Where is our equality operator defined? No, that's our sentinel one. This takes const iterator, 2 const iterators, and requires that is that the problem? The not equals operator. I feel like that should be automatically defined, but try defining it ourselves, see what happens. Okay. Well, first, the equals error went away, right? This is a different one. None which takes an iterator true. Trying to match iterator true to iterator false. Oh, so this is doing expression rewrites. So I shouldn't need this implementation. So obviously just have some issue with the converting constructor. What happens if do we mark a const iterator constructor explicit? Let's check. Iterator. No, this is our converting constructor. Requires that we are const and iterator 2 v is convertible to our base iterator type. I'm gonna try and explicitly specify one which looks like this and see what happens. Because if this is still not picked, then there's obviously something to do with that constraint, maybe. Some line breaks after stid. That shouldn't matter. We can switch to Clang, yeah. Already has a body, yeah. Yeah, let's try switching compiler, see what happens. Should be able to do this fairly easily. Can target Clang. Should already have Clang installed on WSL. So this should just pick it up. So we're now targeting Clang inside Windows Subsystem for Linux. Clang 10 should do, right? Not quite the most recent version, but come on, come on, come on. Have a quick look at our code while it's loading. So like, because my imagining is that the iterator, because this is a friend, it should allow conversions on both the left and right hand side. And it should use the converted constructor to convert the non-const iterator to const iterator, and then call this function. That's what my brain compiler says. Not necessarily the same as a real C++ compiler. It's locking up now. Don't do this to me. Oh, there we go. Okay, building. Ooh, eesh. Do I not have libc++ installed? Maybe I don't. Just compile with libstd C++ instead. Hope that works. Otherwise, we can just try GCC. GCC's compilers are really good as well right now. We just have a bit of catching up to do with MSVC. This looks like I don't have... Oh wait, no, this is just catching more namespace errors. Oh. Use of non-static data member from nested type. Oh. No return statement in const expr. Yeah, that's always good, isn't it? Actually returning the type you're saying you're going to return. Instead of just doing some subtraction and then throwing the result away. Jeez. These are all IntelliSense issues. Any actual build errors? Or is that all just warnings? Okay. No viable constructor or deduction guide. Okay. Substitution failure. For enumerate view. What is our constraint here? Hey, thanks to follow if you're on. This is in our deduction guide right down the bottom. What's our first error? Okay, so we've got at line 54, missing a namespace again. And then again, 139. Okay, this looks like an actual potential issue, unless this is just a failure trickling down from some namespace errors. three-way comparable. Okay. This time. Okay, no matching function. Two ranges begin. Oh, client can't compile libs to CD view interface. That will be a problem. Switch to GCC. I have GCC 10 installed, I'm pretty sure. Guess even better compiler errors. There we go. CMake error. Not even seeing what the error is. Just gonna regenerate. Alright, that generated. Cool. See if we can build now. Come on, GCC, give us some nice errors. Tell us what we did wrong. Okay. Warning, narrowing conversion. Error. Something's private. Line 51. Oh, do we need to friend the non-const iterator, or can we just call base? Base gives us current, right? Instead of remembering how to friend a template specialization. Okay, now we're getting narrowing conversion. Oh, I.pause is I could drag pause out of here, or alright, how do you friend a template specialization? Is it, could we just do friend class iterator non-const? Does that work? Base. No, base returns by copy, you're right. So if this compiles, then oh, that succeeded. Okay. Yeah, so I'll just change this back. Was that just what the problem was? The converting yeah, that's a bad compiler error from NSVC. We had a visibility error within the member initializer list of the converting constructor, and that forced our equality operator to not compile. And then MSVC told us that we couldn't do an equality comparison rather than our converting constructor was having a visibility lookup error, which is not great. Definitely going to be filing a bug on that one. But hopefully now we can run this. Oh, and it immediately exits, but hopefully now we can go back to MSVC and this will just work. And we can play around here a bit. So we should also be able to, since this is a non-const iterator, we should be able to modify it, right? So let's make sure that the initial version works, and then then we could do something like require that I guess we can just have a counter I equals 0, require the index equals I, require that item equals I plus 1. Then we could modify item because it should be a reference into our vector, and subtract 1 from it. Increment our counter. And then we should be able to do the same again. Come on. Come on. There we go. But that should work in theory. Just have a basic version here, or let's just run this and see what happens. Yeah, could require that the A is equal to that. Oh, was that a signedness conversion? Yep. So what is our pause is our count type, and we're taking a difference type. We just that. I'm not thinking too hard about whether this can break or not. Okay, that built. bunch positions, index equals I. Oh, I just forgot to reset I. That's fine. Yeah, and I can do the same thing that you suggested as well. A equals vector 0, 1, 2. Is the constructor deduction going to kick in for me? I can't remember. Especially because, you know, catch 2 does... Oh, did compile. Yay! Nice. Okay. What other test cases could we have in here? Just have this one as my basic vector. Can modify vector. Could have a const vector, make sure that works. What else? Different types. Interested in enumerate, so we could do we could pipe iota. Did iota make C++20? Yes. Test case. Iota. So we could do for ref index item in std ranges iota. Can we just do 0 to 10? Piped into TL views enumerate. That should give us 0 to 10 as the index and 0 to 10 as the item. Have to have an additional counter as well. Could just check index against item, but check it against something external. Acquire the index is I. Acquire the item is I. What's this complaining about? Item, you cannot assign to a variable that is const. Oh, whoops. Thank you. Sit views iota. Still saying no. Iota's. Oh, is iota maybe not in the version of MSVC that I'm using? That's possible. Ranges will be feature complete in MSVC next release. Maybe this is just missing from the version that I have right now. Okay, in which case we could maybe use transform. So we could have our vector. Our vector, and then pipe our vector into std views transform, and subtract one from it. And then pipe that into enumerate. And we should get the same thing. Clang format, very much not dealing with that. In fact, do I need parentheses here? Can never remember what the precedence is. You're not giving me std views transform either? Oh, syntax error. Anyone seeing what I'm... Oh. No, it should have been here. Brackets. Clang format. Trying its hardest, look at that. This is like, there we go. Nice. All right, I'm fairly happy with this. We only got enumerate implemented. I'd hope to do a little bit more, but now that we've got the basics down, maybe we can do a different one faster next week. Can try and do cycle and Cartesian product, things like that. Any last things you folks want me to try, or any questions you have about any of this? I'm going to push this to, in fact, you know, I can do that right now. Oh, there we go. Go ahead, add all of these. All right, so this should, once I push, should be live at GitHub, Tartan Llama, ranges. There we go. So if you want to play around with it, I'll add a README file. I should, in theory, have actions, GitHub actions set up already on this. So this is now going to build and run all of the tests which we just wrote, because I set this all up already. So yeah, I'll make a README file and add the little badge from GitHub Actions to it, and it'll be all very nice. Yeah, this will probably take a little bit. But yeah, thanks for everyone who joined the stream. Yeah, zip. Yeah, so zip is an interesting one because zip really requires changes to vector, to tuple and pair. If you go and read, which paper is it? So there's a paper on zip, and where is it? Here we go. 2214 describes a bunch of issues with tuple and with pair that are required in order to make zip work properly. So I probably won't implement zip, but yeah, I can certainly try and do like cycle and count Cartesian product, and I can have a look in range B3 and see what other things are. I don't think they're breaking changes. I think they're purely additions. But yeah, if you want the details, I'd go and read this paper. I haven't gone through it fully, so I can't remember all of the details. But yeah. Yeah, if you want to read it, you can just go to paste in the chat, wg21.link/whatever the paper number is. And then if you click that, then it'll take you right to the paper, which is pretty nice. Cool. All right, thanks very much, everyone. I hope you enjoy the rest of your week, and I'll see you next time.